Welcome back. We are learning about the Thevenin theorem and solving the examples related to the maximum power transfer. Okay, so let's solve this example. Now this is a bit complicated, complex example as compared to the earlier one because it have basically a dependent and independent sources. Again, our target is to find RL for maximum power transfer. So basically RL here, we need to find basically R Thevenin, and then the maximum power that will be basically V Thevenin squared times 4 times the R Thevenin. So V Thevenin is basically, if you remove this one here, that will basically become a part of your circuit. Okay, so what we can do here now, okay, let's take the load outside of our circuit. Okay, so if we make this open circuit here, no current will flow. Okay, so basically we can make this a part of that, right? So I can say that basically I have this 4 kilo, and then I have basically this RL here. This is my load. Okay, now remember, of course we need to find the R Thevenin and V Thevenin. Okay, V Thevenin will be the open circuit here, right? So if we try to redraw this circuit, so how it will look like, we have 3K, we have 1K here, and this is the current source, which is basically 4 milliampere. And then we have a dependent voltage source, which is basically 2000 times of Ix, and we have a 2K here, and this is basically Ix. Okay, and we remove this one, right? So basically this is our open circuit point. Okay, so from here we can find the Thevenin. So because now the circuit contains a dependent and independent source, so we cannot find R Thevenin. Okay, because we cannot remove this dependent source. So we will find the R Thevenin using the earlier technique. What was that technique? That we will find the V Thevenin and we will find the short circuit current. Okay, and we divide them. And to get the short circuit current, again you need to redraw the circuit. Okay, by making the load point short circuit. So let's do that. So we have 3K here. Again we have 1K. So this is a basically, this example is a combination of different examples like we did in the previous videos. Okay, so we have 2000 because it has dependent independent sources, and also we are basically computing the maximum power. So 2K here, and now this point was open circuit, right? Now we will make this one short circuit here. Okay, and we will find basically this short circuit current. So once we find this open circuit voltage, this short circuit current, this is the circuit for that, we can calculate the R Thevenin. Okay, so now to get V Thevenin or open circuit voltage, this is our circuit. Simply you can use this V Thevenin is basically the voltage drop across here. So I can use mesh, I can use nodal. Okay, whichever technique you want, okay, we can apply here and we can get our answers. So like we did earlier examples by making a super node, right here. So let's try to apply the mesh here. Okay, just for a different flavor. We can use nodal here also. Okay, like we can make this one a super node. We write a nodal equation here and we can get the answers. Okay, but because we did nodal many times, so let's apply the mesh here. Now to apply the mesh here, we can notice basically we have a super mesh here actually, right? Because this is the current source which is shared between the two nodes. Okay, so if I define the current here as I1 and the current here as I2, which is basically also Ix, right? Okay, so I can write the equation for this one. Okay, this super mesh. So that super mesh equation will be what? The direction of the current is upward. It will be I2 minus I1 is equal to 4 milliampere. Then we can write one equation for this whole super loop. So starting from here, what will be that? 3 times of I1. Okay, then plus 1 times of I1. Okay, then we are here minus 2000 times of Ix. So Ix is basically I2, right? So I2, then 2 times of Ix. Ix is basically I2 is equal to 0. Okay, so this is the equation for this complete one. So if we simplify this one, so we have here 3 times of I1, 1 times of I1. That will be 4 times of I1. Then we have basically, so this whole thing is basically in Ks. So this is basically 2000 could be 2K. So I can write this as 2 times of I2. And here I have basically, this is again 2 times of I2, right? So this will be cancelled. So basically I1, okay, we can get different values, right? So this and this will be cancelled. So it means 4I1 will be equal to 0, right? So in this case, what will happen now? So this says that basically 4I1 is 0. So I1 is basically 0. So if I1 is 0, we can get value of I2. What will be I2? I2 will be 4 plus I1, right? So I1 is 0, so it will be 4 milliampere. Okay, so I2 is basically Ix. So if I know I2, I can easily find Thevenin. So Thevenin is basically nothing, 2 times of I2. I2 is 4 milli, so 2 times 4, 8 volt. Okay, so we get our open circuit voltage here. Now let's try to find out the short circuit current. So for the short circuit current, okay, remember the principles. Whenever we have a short circuit branch parallel to anything, it will make that thing also short circuit, right? So 0 ohm parallel with 2K, that will just make it 0. Okay, so let's redraw our circuit for this case now. So we have 3K here. I have this top 1K. We have this current source with the value of 4 milliampere. We have this dependent current source, this one, which is basically minus plus. What is the value? 2000 of Ix. And then this 2 will become basically short circuit 0. Okay, and we want to find this short circuit current. Okay, so our circuit will simply look like this one. Okay, so Ix was basically here, right? So when this become basically all the current will flow through short circuit, no current will be flowing through this one. So basically Ix is 0. So if Ix is 0, it means 2000 times Ix, this will be 0. So 0 means short circuit, right? So what I can do here, I can just simply remove this one, right? This voltage source with a simple, okay, short circuit point, okay, because this thing becomes equal to 0. Okay, so this is our circuit. Now this 4 milliampere is coming. This could divide to this branch and this will go to this branch, right? So because we have a short circuit, so all the current will flow through short circuit. Current always follow a low impedance path. So Is, we can directly calculate, it will be basically 4 milliampere. Okay, no current will be going through this path. Okay, so we have short circuit current, we have open circuit voltage, we can calculate R Thevenin. So what will be R Thevenin? R Thevenin value is V Thevenin is 8 volt. I short circuit is 4 milli. So that will be 2 kilo ohm. Okay, so we have R Thevenin 2 kilo ohm. Okay, so if you want to make your equivalent circuit, you can put the R Thevenin here. We can get the V Thevenin here. Now next target is to calculate the load maximum power. So that will be V Thevenin square. That is basically 8 square divided by 2 times of R Thevenin. And R Thevenin value is basically what? 2K, right? So basically 64 divided by 4K, okay? Or basically we can say that so value of R Thevenin comes out to be 2K, right? Because like R Thevenin is V Thevenin, which is basically 8 volt divided by the short circuit current, right? Which is basically 4 milliampere. Okay, so we can put that here. So actually not 2K, okay? this is a small issue here, not small issue basically. So we get RThevenin, right? So for that, we need to draw our circuit here basically. Okay, so let's try to draw the circuit. Okay, that will basically clarify this thing. Okay, the equivalent circuit. So in the equivalent circuit, we have basically load that was here, right? Then we have this 4 kilo ohm here. So we get RThevenin of 2K, right? So this is basically coming RThevenin 2K. And then we have this voltage source, which is basically VThevenin. That is basically 8 volt. So this is Thevenin equivalent circuit. So now for the maximum power transfer, we are basically taking this thing as our reference, right? So by looking from this end, for this circuit, this will be like if you want to calculate the equivalent resistance. So we make this one open. So this one becomes short circuit. So 2K and 4K in series. So basically RL or actual power RThevenin maximum power transfer, that will be 6 kilo ohm. So that's why PL will be VThevenin square 8 square divided by 4 times of 6. Okay, so this comes out to be basically 8 over 3 milliwatt. So this is how basically we can solve such kind of advanced example which contain dependent independent sources, and we find out each and everything. Thank you so much.